In this problem, we have a crate that is moving down this slide. Its vertical position y is a function of its horizontal position x, and that function is given. When x equals to 10 feet, the crate has a speed of 20 feet per second. The speed is simply the magnitude of velocity, so its velocity when x equals to 10 feet is 20 feet per second. And we need to determine the direction of the velocity. Also, its velocity is increasing at 6 feet per second squared, and that is basically a t, the tangential acceleration, because the tangential acceleration is responsible for changing the magnitude of the velocity, while the normal acceleration is responsible for changing the direction of the velocity. So that's what the problem statement gives us. So we need to determine the magnitude of the crate acceleration as well at this instant. And the acceleration, total acceleration, equals to the tangential component plus the normal component. Therefore, if we can find the magnitude of the normal acceleration, then the magnitude of total acceleration equals to a t squared plus a n squared. So let's first look at the first half of this problem to determine the direction of the crate's velocity. We know that the direction of the velocity is always tangent to the path. Therefore, the direction of the velocity is simply along this tangent line. And we need to determine that, and we specify that by an angle theta right here. So this angle theta is made by the x-axis and a tangent line at this point when x equals to 10 feet. So how do we determine this theta? If we draw a triangle here, so we can draw this red triangle, and we realize that tangent theta equals to the slope at this point. In other words, tangent theta equals to dy dx evaluated at x equals to 10 feet. So if y equals to 1 over 24 x squared, then dy dx equals to 1 over 12 times x. Therefore, at x equals to 10 feet, the slope equals to 1 over 12 times 10, which is 5 over 6, and we said that that equals to tangent theta. Therefore, theta equals to the inverse tangent of 5 over 6, and that is 39.8 degrees. So that's this angle right here, and that specifies the direction of the velocity, which is at an angle of 39.8 degrees with the horizontal direction. So for the second half, to determine the magnitude of the crate's acceleration, we already said that we need an, which is the normal acceleration. And an equals to v squared over rho. The rho is the radius of curvature, and we already know what v is, which is 20 feet per second. That is a given. So we only need to determine rho. And if y is expressed as a function of x, then rho can be determined through this equation, which is 1 plus dy dx raised to the second power, this whole thing raised to the 3/2 power, divided by the second derivative of y with respect to x, absolute value. So we already know that dy dx equals to 1/12 dx. Therefore, the second derivative equals simply a constant 1/12. Therefore, again, at x equals to 10 feet, rho here equals to 1 plus dy dx equals to 5 over 6 raised to the second power. The whole thing raised to the 3/2 power. On the denominator, that is the absolute value of 1/12. So we can evaluate this rho to be 26.47 foot. Substitute it into this equation. AN equals to V squared, which is 20 squared, over rho, which is 26.47, and that equals to 15.11 in the unit of a foot per second squared. And substitute everything into this equation. A equals to square root of AT squared plus AN squared, and that equals to 16.3 foot per second squared.